All right, everyone. Sorry I can't be there, but take a moment to try to factor out this expression. Uh, if you guys don't know how to do it, that's okay. We'll go over factoring again later. But take a moment to look at this one and see if you can do it. All right. Hopefully you enjoyed that bell work. Take a moment, get your homework out. Go ahead and correct your homework. This is only going to have so much time on the video for you to correct your homework. But go ahead and do it. See what you get, score it, and then next time when I return to school on Tuesday, we'll go ahead and take those scores. But we won't have time to correct this assignment, so make sure you score it. Alright, I hope that was enough time to correct the homework. Go ahead and have the sub. Go ahead and have the TAs pass out the classwork. Now this part is not in the classwork, so if you guys want to take a moment, get a piece of scratch paper out, and then we'll look at these problems. But you may want to take notes on this stuff because it has some of the terms that we're going to be using. They'll be on the test as well. You're going to have to know this stuff. So please take notes. All right, when addition or subtraction signs separate an algebraic expression, those are called terms, okay? So notice negative 4x is a term, 12 is a term, and x is a term. When terms have the same coefficient, not the same coefficient, but the same variable or variables, they are considered like terms. If one of the terms, like this one, does not have a variable like x, as these ones do, then it's just considered a constant, which is what this says here. Notice they've kind of color-coded these as well. We've got the three terms. Like terms are in red, constants in green. Okay? Constants are just numbers. Maybe that's more simple for you. So in this problem, we're going to look at these two expressions, and all we're going to do is identify the terms, like terms, coefficients, and constants. That's it. We're not going to be calculating anything. We're just going to look at the terms. So let's take a look. All right, I'm going to go ahead and do this one on the left, and then I'll give you guys some time to do the one on the right. So let's look at that one on the left. Here we have the terms n. Remember, they're separated by addition and subtraction, right? Then we've got 4n. Now this next term, notice, it has a minus in front of it. That means we consider it a negative 7n. So in the terms, right, even this one that's going to be considered a negative 1, the terms will always take the operation to its left, meaning addition or subtraction. Now we don't usually write addition or the positive signs there, which is why you don't see those. But you can if you want, if that is helpful for you. But just know that usually we don't. Okay, those are the four terms. The like terms, let's go ahead and take a look at these. So we're going to look at first the n. Okay, are there any other terms with n's? Yes, there is. We have n. There's a 4n. And a negative 7n. Some of you guys were looking at the terms list, which you may do as well. So these three are all like terms, okay? But let's go and take a look at the one. It is a constant because it does not have an n. But notice, does it have any other like terms? No, because there are no other constants. These terms all have an n. So they are not constants, and we could list that down here as a constant. We have a -1. The coefficients, we can go ahead and look at these. The coefficients are the numbers being multiplied by the letters. So what number is being multiplied by this n? A 1 is. What number is being multiplied by this n? 4. And the n here? -7. Those are the coefficients. Alright, so that solves the first one. Go ahead and take a moment and do this one here, okay? And then we'll show you guys the answers in a moment. Alright, hopefully you guys found that helpful and useful, and that you guys know the difference between terms, like terms, and coefficients and constants. But there are your answers. Alright, take a look at this example as well. Notice all we've done again is identify terms, like terms, coefficients, and constants. The terms here, I notice they put an equal sign here, so we really only need to look at it like this. We've got the 6n, the -7n, the -4, and finally the n. Okay? Those are the terms. Like terms are the terms with the n's. Coefficients are the numbers being multiplied to n. And the constants are the numbers without any n's. Alright, take a moment and try A and B. List the terms, like terms, coefficients, constants. Alright, there are the answers to A. Now, if you guys can't see the yellow writing, just have one of the TAs turn the lights out so you can see it. And there are your answers for B. Once again, the terms are separated by the additions and subtractions, though they keep the operations. The like terms have x's, and the constants are like terms as well, so they're paired in different colors. The coefficients are the numbers being multiplied by the letters, 3 and -3, and the constants are not being multiplied by any letters. Alright, if we want to write an expression in simplest form, we simply need to combine the like terms. In some cases, yes, you may use the distributive property. Alright, so let's write these expressions in simplest form. So notice here we have an x and there we have an x, right? So if we combine those x's, how many x's would we have? Well, here we have 5 and 9, so if we combine those, you'd have 14 x's. Now, there's no other constants to combine with this 4, so this is just 14x plus 4. That's our final expression. That is simplified. Notice in this one we have 3D, and that's a 1D. So if we add the 3D and the 1D together, then we have 4Ds. And notice, again, there's no other constants to add to that 2. We can just write it like this. Alright, go and take a moment and look at some of these examples. And now that we've done that, go ahead and try C, D, and E on your scratch paper. All we're doing is simplifying these. All right, there's your answers. Once again, we have a 4z minus a 1z. If we combine the 4 and minus 1, we'd get 3z's. Notice on this one, the 6 nothing happens to the 6, but if we combine this negative 3n plus 3n, then we'd be left with 0 n's, and we don't have to write that in there. So the answer is just 6. Same with this one, we'll combine the g's. 2g minus 8g is a negative 6g. In the calculator, you would write or type in 2 minus 8 to get that negative 6. And then also we need to combine the negative 3 and 11. Negative 3 plus 11 is a positive 8. So that's where that answer comes from. All right, here's one of those percentage problems. Go ahead and take a moment, take a look at this one, and see if you can solve it. All right, here's part F. We're going to use the same example. However, instead of a 5% markup, we're going to mark it up to 8%. And we can use this. Notice, some of you guys know already what to do. We're just going to change this 0.05 to 0.08 instead. Alright, so how do we get this one? Well, the markup, right, if you guys remember this, hopefully, you're going to be paying 100% of the price. But since we're going to mark it up another 8%, you're really paying 108% of the price, which is where this equation comes from, or expression. Then we just need to find the total cost of it, which in the previous problem, the price of the jacket was $35. So you're going to pay 108% of the $35. Yes, there's a decimal there. And when you multiply that, you get $36.75. If it is unlabeled, you will not get the credit. Here's another example for you to look at. Go and read it, look at the work, and hopefully that helps you in order to determine the price and the expression. All right, you guys take a moment to do this one. You have some money, your friend has $50 less than you. Write an expression in simplest form that represents the total amount of money you and your friend have. So we're looking for how much money you have and how much money your friend has. So friend, okay? And we're going to add these together to find the total. Since this is just an expression, we don't really need that total there, the equals there. We know that your friend, in comparison to you though, your friend has however much you have, but $50 less than that. And you have however much you have. And if we add those together, that would be an expression for how much money you and your friend have. Now the problem is we've got to combine these to make it in simplest form. And here we have 2u's. And we'll subtract 50 from that. And that would give us the total amount that you and your friend have. That's your final answer. And the reason that is because this can't be simplified any further. All right, I'm going to give you guys some time to do these. I'm not going to explain them, but you're going to see the answers here in just a couple minutes. Just take a moment. On this one, identify the terms, like terms, coefficients, and constants. And then on this one, you're going to simplify, so you're just combining like terms. There's nothing to solve for, so just leave it as an expression. Number 3, though, we can solve this one because it gives us the original price. So you should be able to do that, and it also gave you the expression. So simplify the expression, and then determine the cost of the game after sales tax. On this 4th one, all you're going to be doing is writing an expression in simplest form. So after you combine the like terms, you should have an expression that you can write to represent this situation. All right, you guys, take a look at this one. See if you can solve it, and see if you can fill in the table as well. So make sure to be very specific with your whys and why nots. Okay, because on the test, you will have to have a good explanation there. All right, for each context, 4 algebraic expressions are offered right here. We've got to determine if these expressions are correct, and we'll evaluate it when x is 7, all of them, whether they're correct or not, and determine if it worked. And we'll determine why or why not, okay? So on this one, Ryan bought 3 CDs for X dollars each and a DVD for 15 bucks. So he bought 4 items. So notice on this one, on this first one even, there's only 3 items shown there. We have a 3, an X, and a 15. Now while he did purchase 3 X's, that means we would add the 3 X's together, not 3 plus X. So this expression is not correct. Let's go ahead and evaluate this. So when X is 7, so since X is representing the number of dollars for each CD, in other words, we're saying if each CD was $7, how much would he have spent? Well, if that were the case, looking just at the problem, we can determine that the 3 CDs at $7 each would have been $21, plus the 15 would have put us at $36. However, when we solve this expression, we have 3 plus 7 plus 15, which is 25. So no, it did not work. It should have been $36. So it does not equal $36. Okay? Let's look at this next one. 15 times x tells us that we have 15 x's. A group of 15 x's. Okay? Now that means that since there's 15 x's, that means they would have bought 15 of the CDs. Okay? So as it turns out, this one also is no good. And if we solved it, 15 times the 7 would be 105 plus the 3. That would be 108. So did it work? No, it did not. Because once again, it needs to equal $36. Okay? And for the other reasons that I said, right? We're not buying 15 CDs. On C, notice we have the $15 DVD, and then we have 3 X's being added together. So yes, this one will work. And how much would it cost? Well, 15 plus 7 plus 7 plus 7. You got it, 36. And yes. Why? Because we have 1 DVD and 3 CDs. Okay? This fourth one, once again, we have 3 CDs and 1 DVD, so yes. 36, yes. And 1 DVD, 3 CDs. And that completes the table. All right, we're going to give you this situation as well. This one I'm not going to explain, but go ahead and we're going to show the answers here in a couple minutes. That doesn't mean you shouldn't do the work, okay? Do the work. Look at the expression, see if it's correct, evaluate it when y is 6. And since y is the jelly beans, that means that Syl, I guess, would have eaten 6 jelly beans. Okay, and that should satisfy what it's saying up here, okay? So go ahead and take a moment, do that. We'll show the answers. All right, go ahead and try this one now. This one's a little bit different because we're looking at a discounted price. So go ahead and take a look at the expressions here and fill in your table. Once again, be very specific with your why and why nots. All right, now take a moment to look over this example where Jill bought 12 apples and Jen had X more apples. And this should help you to understand what we're going to be doing in the next couple examples. All right, now it's not completely necessary that you use the models, but we are going to write an expression for this. But first take a moment to see if you can do one yourself. And remember, if it's helpful for you to use the models, do it. Okay, if not, then you may not need it. But most people do find that they are helpful. So see if the model helps. If not, write the expression. But if you're wrong, I highly suggest using the models. We'll go over this in a minute. All right, here we go. This is the answer right here. Okay, 12 minus p. So, and I don't know why they're using p. That you can just use any letter that you want. Just be careful with some of the letters. Sometimes L's look like 1s, O's look like 0s, and so forth, okay? Evan won P tickets fewer than Josh, so if we were to not use these, but we just looked at it in terms of Josh and Evan, right? Evan won P tickets fewer than Josh, so Evan had as much as Josh, but he had P less than whatever Josh had. But it told us right here at the beginning that Josh had 12 tickets, so when we find whatever Evan had, it would be 12, and then because that's what Josh had, and then we would subtract the P, and I don't know why they're using P, but whatever, okay? And that's why the P was right here as well. So this is the model, and notice we have this rectangle here to indicate what Josh has, and we don't know what P is, but we just know that it's some value less than Josh, which would give us the number of tickets that Evan had. Okay? Again, this is an unknown value, which is why in the end, this is our final expression for Evan. All right, go ahead and try this one. See if you can write the expression. If you do write the expression, see if you can draw the model for it. All right, Tim is 3 years younger than his brother. Right here it says, all it's saying is that we don't know how old his brother is, but that Tim is 3 years younger, okay? So as time moves forward, Tim will always be 3 years younger. Now, Tim is 3 years younger than his brother, right? And since it told us to use y as his brother's age, that's why it's y minus 3 there. Because we could look, if his brother, for example, was 10, then how old would Tim be? Even if you didn't have the model, even if you didn't have the expression, you would know that Tim is 7 years old, right? And that's because if his brother was 10, you would subtract 3 and get the 7, okay? But this right here is the expression. The model, notice, the brothers bar here, we don't know how long it is. All we know is that we're going to have to remove, as we did in the expression, we're going to have to subtract 3 years off of his brother's bar to get Tim's age. All right, take a moment. There's going to be a few more questions. Go ahead and do those. I'm not going to go over these ones just because you have examples. We have the answers. But check your work, all right? Read what it says. Sometimes it goes into great detail about why the answers are what they are. But I hope that you find that helpful. And if you have any other questions, bring them when I get back next time. Alright, create a context and draw a model for the following algebraic expressions. This one's not too bad. For the model, this bar could represent R, and then this would represent an additional 15 right here. So that would give us a new bar, this one, which would be R plus 15. Okay. Now a context for something like this would be, usually most of you guys seem to like to use money. So we would say if you have a certain number of money R and you make $15 more, how much money do you have? Or you could go along with some of the examples we just previously saw there. You have 15 more dollars than R, maybe that's Roger. So how much money do you have? You would have R plus 15 because it's Roger's, and 15 more. Alright, on these next few problems, you need to write the expression for the given problem. And you can use a model just if you want. Again, I hope you find that they are helpful for you though. All right, that concludes this lesson. So right now would be a good time. The sub, go ahead and have the TAs pass out the homework now. But if you guys are still struggling with this stuff, check the homework, just see if you can do it. If you're still struggling, you're going to need to get to math lab after school on Tuesdays, Wednesdays, or Thursdays. In addition to that, you can have me zap you, but you're going to have to tell me so that I can green zap you. Also, you can bring whatever questions you have to class next time, but just understand we're going to have to go over the lesson on Tuesday, okay? So thanks, you guys. Be good for the sub, and we will see you guys next week.